Welcome to Study Loop.
Okay, so in this problem, we have a voltmeter that is connected in parallel with the resistor R, big R. Then we have the EMF voltage, and then we have the internal resistance. So we need to find the EMF voltage from this setup. Now, the first assumption that we're making here is since the voltmeter has high resistance, so there's no current passing through the voltmeter because of high resistance, most of the current is going to R. So if there's no current passing through it, we can use our Kirchhoff's law, and then if we do so, and if we take our loop rule and take clockwise direction, then we have this following equation. So we have two cases here for two different R's. So in the first case, we have this. So we start from the bottom right corner, and we see that there's a voltage gain, so it's positive. Then we say for the first case, it's, let's say, I1. So I1 times R, and since they are in the same direction, we have a negative sign. Then I1 is going to big R, so there's a negative sign again, so that gives me 0. And we know that the voltage drop in voltmeter should be equal to the voltage drop across the resistor. So V1 is the voltage drop across the resistor, and from Ohm's law we get I1 times R. Now for the second case, it's the same thing, but we consider I2 instead of I1. So let's say case, uh, well, I guess I don't need to write it, it's already there. So yeah, so this is going to be case 2 for I2 for case 2. So it's the same equation again. Now if we solve for it, so let's first solve this equation. So we get an expression of the EMF voltage in terms of I1 times R plus big R. And let's call it R1 because it's the first case. And from here, we can actually replace I1, and that will give us psi equal to V1 over R1 R plus big R1. Right. And similarly, in this case, this thing is common for both of them. So our psi will be V2 over R2 R plus big R2. Right, so now we have two equations and two unknowns. So one is this and one is this one. So if we take this expression and this one from the first case and then equate them, we have V1 R1 times R plus R1 equals to V2 R2 times R plus R2. And then if we solve for R, little r from there, we get R1 times R2 V2 minus V1 divided by V1 R2 minus V2 R1. So now the given values for R1 is 35, R2 is 14. Then we have the voltage. So V2 in our case is 8.1 volts, and V1 in our case is 9.7 volts. Right, so if we plug in all the numbers here, we get little r as 5.308 ohms. And since we know little r now, so we can plug the values here and solve for psi, or we can plug the values here as well, because like the other terms are all known. And yeah, solve for psi. So let's plug the value in the first case. So psi will be V1 over R1 times R plus big R1. And then we have 9.7 over 35 ohms. Then 5.308 ohms plus 35 ohms. And that gives us 11.7 volts. So that's our EMF voltage. Thank you.